This worksheet shows the end result of a construction that is a simulation of the central limit theorem. It begins with a population called index, which has 16 members, and they're named 1 through 16. The random variable is called RV, and the values of the random variable are plotted in this graph over here, so that, for example, the value at member number 5 is 0.2, and so that's this blue bar right here. And I'm going to calculate the mean and the variance of this random variable. The mean is 0.211 and so forth, and the variance is 0.05. And in connection with the central limit theorem, I'm also calculating the variance divided by 5, because what I'm going to do is consider what happens when you take samples of size 5. How many samples I'm going to take? I'm going to take 25 samples of size, take that back, 29 samples of size 5. So according to the central limit theorem, the variance of the sample mean is going to be the variance of the original random variable divided by the sample size, which is 5. So that's 0.0109. On the right over here, I have a button which retakes 29 samples of size 5 over and over again, but each time that it takes 29 samples of size 5, it plots a probability distribution over here. And my point is that as I do that over and over again, I get a new set of samples of size 5, and I plot it, and roughly speaking, and this is the point of the central limit theorem, roughly speaking, it's sort of a bell-shaped curve. It's not always bell-shaped, but a lot of the time it's bell-shaped. And this recalculation is being forced by pushing this button that changes one cell in the worksheet, and it's a property of Excel that when you change one cell in a worksheet, any functions that involve random numbers get recalculated automatically, and that's why I get a different graph each time. So I'm going to construct this whole thing from scratch before your very eyes. I'm going to begin by saving my worksheet as a .xlsm file. That's because that button that I'm going to create requires a macro, which we're going to come back to that. The name I'm giving it is clt-simulator-a, and file name extension .xlsm. Now, one thing I like to do is set my whole spreadsheet as decimal numbers. So I'll go to the Home tab, come down to Number, and at that point, every time I put in a number, it'll have, by default, 2 decimal places. Now, I'm going to create a population with 16 members, and I'll label the population. I'll just call it Index for a reason that will become clear later. And I'm going to name the members of my population 1 through 16. So I'll put a 1 and a 2, and then I'll select those 2 and go to the lower right-hand corner and go down to 16. And now I have my members of a population. I'm going to remove the 2 decimal places because I don't need those, and I'm going to center everything. Okay? And I'm even going to center the label. At this point, all I have is a population. I don't have a random variable. Now I'm going to define a random variable. I'll call it RV. And RV is going to be a very simple calculation based on the members. I'm going to take the reciprocal of each member of the population as the measurement. So I write equal, and then I click on the member, and actually what I do is I equal 1, divide by, and click on the member. And so 1 divided by 1 is 1, no problem there. I'll click on that and then copy that down by going to the lower right hand corner. Now I have measurements of a random variable, and I want to see a graph of these measurements. So I'm going to put in the word done over here to make the graph come out nice. And you know what? I'm going to center the random variable values. And now I'm going to select everything down to and including the word done. I go to the Insert tab, go to Recommended Charts, and I like this bar graph type of graph over here. It's called RV, and now we have a complete statement of a random variable on a population. It just so happens that these values decrease in a way that looks like a power law. Let's not go into that, but instead let's calculate some statistics. We want to know the mean and the variance of this random variable. So the mean, let's make a label here, mean and a label variance, and I'm going to calculate the mean as equal AVERAGE, and select the values of the random variable, close parenthesis, and my mean is 0.21. Let's give that a couple more decimal places and go on to the variance, and I'm going to calculate the population variance, equal VAR dot P, open paren, select the values of the random variable, close, and so I've got about a 0.05. Let's give that a couple of decimal places. And there you go. I have a mean and a variance. Now, the Central Limit Theorem says that if I take samples from a population of a random variable and calculate the mean of each sample, then the sample means are normally distributed with a mean that's the same as the mean of the original random variable, but with a variance that's equal to the variance of the original random variable divided by the size of the samples. Now, what I'm going to do is I'm going to take 29 samples of size 5 from this random variable, okay? And here's how I'm going to do that. I'm going to use a special Excel function called index. So I'll go to, let's say, over here, column K, row 2. I go like this, equal, and I'm going to use uppercase now, index, and here's what I'm going to do. I'm going to index into the values of the random variable at random. So I'm going to choose in the random variable RV, so I'll go RV, lowercase RV, open, comma, and now I'm going to choose one of the indexes at random. So I'm going to use RAND, let me use uppercase, RAND between, and between 1 and 16. And now watch me get into trouble. You'll see why I get into trouble. I press enter, and it tells me I haven't named something. What have I not named? I have not used the label RV as a name for the values of the random variable. So I'll just select the name, the label, and the values, go to the Formulas tab, click on Create from Selection, say OK, and now I have a value. What value do I have? Well, it says 0.5. It looks like 0.5 is the value of the random variable at the member named 2. Fine. If I click anywhere else in the spreadsheet and see that Excel automatically recalculates the spreadsheet based on a random choice, I'm getting 0.08. Now, do I have a 0.08? I have a couple of 0.08s. Okay, there are two members with name with value 0.08. Okay, if I change it again, let's try it again, 0.33. Oh, okay, member number 3 is 0.33. Okay, you get the idea of that. All right, so now here's what I'm going to do. I'm going to take a sample of size 5 by copying this across 5 times. There you go, Control R. Now I have a sample, one sample of size 5. Let's see, we've got a 0.5, yes, that's member 2, 0.17, that's member 6, 0.1, that's, where's 0.1, that's member 10, and 1, That's member 1, and another 0.17. Hey, this is a sample of size 5. It happens to have repetitions. Now, what I'm going to do is I'm going to copy this sample set of formulas down 29 times. Okay, so I'm going to go down. Let's see, I'm in row 2, so 29 plus 2 is 31, so I'm going to go to 32. And I believe that is now a set of 29 samples of size 5. Let's double check that. If I select this column here and I look down here, it says it's a count of 31. Oh, I added 2 extra ones. All right, take away 2. Not a real problem. You notice, by the way, when I change the spreadsheet, all of these recalculate automatically. Let's double check again. Select this, and now I have 29 samples of size 5. Fine. Next step. I want to calculate the mean of each of these samples. Well, that's easy. I'll go like this. I'll go to column Q and I'll say equal AVERAGE, open paren, select my sample, close paren, and now I have the mean of the first sample. I want to get the mean of each of the samples, so I'll select that, go to the lower right hand corner, and have that copied down automatically. And now I have 29 sample means from this original random variable. Let me center all of this. I like to see numbers in the middle, so I'll center that. Okay, at this point, we're well on the way, but what I want to do is I want to plot the probability distribution of these sample means so that we can get some idea of how this power law looking graph of the original random variable becomes some other graph. Okay, so in order to do the graph, I need to create bins and assign these to bins. Now, what I'm going to do is I'm going to make 11 values for my bins. The way I'm going to do that, in order to make it an adaptive graph, I'm going to calculate the minimum of my current set of 29 sample means. So that's going to be equal min, open paren. Then I'm going to select these, close paren, and the minimum right now is 0.08, and that looks like it's down here. I also want the maximum. You'll see why I do this in a second. Equal max, open paren, select these guys, close paren, and I have a maximum now of 0.54. And does that look about right? Well, is there a 0.54? Yeah, there's a 0.54 right there. Okay. So what I'm going to do is I'm going to take the range between the minimum and the maximum and divide it by 11. And then, well, you'll see what I do with that. So I'm going to, first of all, calculate that. Equal, open paren, the maximum minus the minimum, close paren, divide by 11. All right, so now I have an increment for the width of my bins. And this is an adaptive increment because if I change the story, the increment changes. Here it is 0.04. And now it's back to 0.03. Okay, so what I want to do is create my bins to the right of my sample means. I'll tell you what, let me color these in so you know exactly what I'm working with. Here are my sample means. That's the simulation in a way that I'm going to elaborate on. So my first starting point for the bins is going to be hold on a second. Let me just double check what I'm doing here. Right. I'm going to take the minimum value, so I go equal. I'm going to take the minimum value and subtract this increment that I calculated. Now, when I want to use this minimum value, I could give it a name and everything, but instead to create an absolute reference, I'll just put $ on the location of that. And now I'm going to subtract this increment so that I start below the lowest value, and I want to make that absolute also. So I'll go like that. Now, so my first bin starts at 0.04, which is below 0.08 by the amount 0.04 for this particular random choice of samples. So now my next thing is going to be equal to my preceding, the left end of the bin, plus my increment. And again, I'm going to put $ on that over here. And so my first, okay, fix that. My first bin, I have to put an R2. Sorry, R1 over there. And now it still gets in trouble. Okay, hold on a second. Let's make sure I do this correctly. R1, and then, oh yeah, the $ go in front of the column and the row. So there you go. So my first bin goes from 0.05 to 0.08. Now I'm just going to copy that down to make 11 bins. And probably go down to about here, Control D. Now how many do I have? Hold on a second. I look at the count. Ah, I actually have 11. There you go. Now, one more thing. At the last one, I want to give it just a tad more count by a small amount, because I discovered that since you want the frequencies that we're going to calculate for these bins, they have to add up to 29. Okay, they have to add up to 29. So I'm going to have one more bin here. Copy this down. But over here I'm going to add plus 0.1. There's a reason for that that has to do with the fact that sometimes the last two sample means just might turn out to be equal to each other. And the way the frequency function works, which is what I'm going to use to create the graph of the frequencies in these bins, it counts everything up to but not including the top value of a bin. And I want to make sure that I always add up to 29. So at this point, I'm going to be creating a graph of these frequencies. Well, I got to calculate the frequencies. So I select cells to the right of the bins. I go to the formula tab and I go equal frequency, open paren. I select my data, which are these 29 sample means, comma. Then I select my bins, and I close paren, and I go Control Shift Enter. And I've entered too few arguments. And the reason why is because there should have been a comma there, not a period. All right, I can fix that. And now I have a bunch of frequencies. I probably have one too many, so I'll take that away. Well, I selected too many. Okay, you know what? I'm going to redo that because I want it to be exact. So let's just do that again. Equal frequency, open paren, select my data, comma, select my bins, close paren, Control Shift Enter, and now it does what I want it to do. So I'm going to graph the histogram, so to speak, of my frequencies. So I'll use the word done over here again, and graph this like so. Go to the Insert tab, recommended charts. Oh, here's a graph. I like the bar chart. And there it is. Hold on a second. Let's just put this over here and look at it. I'll put this, I don't know, I'll put it under here. Fine. You like that? Now, that's not bell-shaped. It's not power law shaped. But let's face it, every time I change some cell, it's going to recalculate. And I get another calculation and another calculation. And they sort of want to be bell-shaped, but I have to also say, sometimes it's really weird, it's generally not bell-shaped, but sort of bell-shaped, skewed to the right. Gee, I wonder whether that has anything to do with the fact that my random variable is also severely skewed to the right. Well, here's the thing. We're doing very small population size, very small sample size, and let's face it, a very small number, 29, of samples of size 5. And so the extra credit a student could get would be to redo this whole thing, but let's say with a population of size 1,000 and sample size of 20, and maybe doing 50 samples of size 20. And the purpose, by the way, of doing these multiple samples is to approximate the ultimate story, which would be an infinite number of samples of an infinite size. And when you do that, if you could, the theorem says, the central limit theorem says, you're going to get a normally distributed result with mean equal to the original mean, 0.2113, and a variance equal to the original variance, 0.0544, divided by the size of your sample. In other words, if your sample was very large, you would have close to 0 variance in the result. All right, but for now, we're just simulating with very small numbers. The only thing that I want to do further is instead of changing a cell one at a time in order to see a new graph, I want to create a button that allows me to just see the new graph each time I push the button. All right, so I'll tell you what, let's go to the Developer tab, which on a Mac you can get by going to Preferences and making sure that under Preferences you've clicked the box that turns on the Developer tab. And then under the Developer tab, I'm going to the Insert button and going to Form Controls and the button at the first row, first column over here, and I get a little new kind of left mouse button area that's going to be a button, and I'm just going to say OK on that, and I get a button there. And what I want to do is I want to rename the button. So it's selected now. If I right-click on that and let go, unreliably, I don't always get to see the thing that I want to see, which is to rename the label on the button. But it can be done. You got to keep doing this. Oh, there it is. You see, it happened. There's probably a rigid, reliable way to get this whenever you want it, but I don't know what that is. Somebody will look that up and let me know. Anyhow, I'm going to edit the text, and I'm going to call it Do It. Do It! Exclamation point. All right, click outside of that. Now, if I click on the button right now, I get a message that says, hey, nothing happening. We're not ready to go anywhere on that. But if I select on that and assign the macro and click on New, like that, I get a place to enter code. That is to say, a program to associate with pressing that button. Now, I'll come back to this because there are a couple of things that I need to assign names to in order to write one line of code, and you'll see what it does in a second. Okay, so I'll tell you what, Alt F11 makes that go away. Alt F11 makes it come back, so I can always come back to the code. But what I want to do is I want to rename this sheet. So I'm going to right-click on the name of the sheet and rename it. I'm going to call it CLT, uppercase CLT. Fine. I'm also going to name a cell over here where I'm going to change a number by adding 1 to it every time I push this button. So I'm going to name that, I'm just going to name that Q. So I'm going to do that in the name box. I now have 2 names in this spreadsheet, Q and RV. That's all I need. Now, Alt F11, go back to the code for this button, Alt F11, and here's the code I'm going to do. I'm going to go range, open parenthesis, quotation mark, CLT, exclamation point, Q, close quotes, close paren, equal, and then the same thing again, range, open paren, open quote, CLT, exclamation point, Q, close quote, close paren, plus 1. And that's my code. What that code says is that whenever this button called do it is pushed, I'm going to increment the cell called Q. And okay, so I'm going to put this code away now and let's see if it works. Push the button. And look at that. This cell over here, let's give it a label, call it Q. Let's make it nice because I defined a named cell, so I'll give it a border and center everything and make it all nice. Okay, so every time I push the do it button, I get a new set of 29 samples of size 5 and a new graph. Okay, that's very convenient. By the way, that's it. That's the basic thing I wanted to do. But there's more that can be done that makes life a lot more interesting in some ways. Okay, so when I do this over and over again, I hope that you can see that sort of it tends to want to be bell-shaped. Again, it's skewed a lot of the time, and that has to do with the original data. What I want to do is calculate the mean and the standard deviation, or I should say the mean and the variance, let's say, of this set of sample means. Okay, so we can do that. I'll do that down here. The mean of the sample means is going to be the sum of the values times their frequency, all divided by 29. Okay, by the sum of these frequencies. By the way, these frequencies always add up to 29. If I select them and I look down here, I see a 29 for the sum, and that's going to always be true. And that's because, well, it's because I set up the bins so well to take care of the possibility of a double value at the end. All right. That being said, let's use equal sum product, and it's going to be the values, comma, the frequencies, close paren on sum product, and then divide by 29. And I get 0.26. Well, isn't that interesting? 0.26, that's the mean of the sample means. And the mean of the original data was 0.21. That's not too bad. Look, these are very small numbers, and I'm not surprised that they're different. But let's do it over and over again. 0.24, 0.23, 0.22, 0.23, 0.25, 0.25, 0.24, and 0.22, 0.21. So I'm in definitely the right ballpark for the mean. Well, how about the variance? Well, to calculate the variance, the way I will do it is I will take the square of the deviations of these values from the mean, multiply by the frequencies, and then divide everything by 29, which is the sum of the frequencies. Okay, so I have to do this calculation in a new column over here, equal open paren, and then I'm going to get the value minus, and then I'm going to get the mean, but I'm going to put dollar signs on that to get an absolute reference. Close paren, and then shift 6, 2 to square it, and then I get that. So I'll copy that down. I'll select that like that. Oh, it's going to eliminate that. Oh, so what? The Q goes away. That Q is still naming this cell, so I'm not in trouble. In fact, I could put the label on the right here. Okay, so I'll put the Q over here. All right, so and I'll even fix that up with my highlight, and there you go. So that's okay. So okay, so now we have the squared deviations, and what we want to do is sum the squared deviations, each one multiplied by the frequencies. Okay, so I can do a sum product again. So I go like equal sum product, open paren, and I'll select my squared deviations as my first column, comma, my frequencies as my second, and close paren, and divide by 29. And I get a name problem. What is the name problem? Because I misspelled sum product, I put a U in there. And now I get a 0.01. Very interesting. Let's give this mean and variance more decimal places. Let's say 4 decimal places, like this. And do it over and over again. And I'm getting 0.01 instead of 0.05. Well, okay. Well, what's the problem here? Well, you see, I said that the mean of the sample means should be the variance of the original data divided by the size of the samples. Well, I have the variance here, but let's calculate equal that variance divided by 5, the size of the sample. Oh, now it's a 0.01. Aha! Aha. I am kind of making my main point here. Let's make my main point large and clear. Okay? I'm going to select this cell, hold down the shift key, select this cell, hold down the shift key, select this, and select this. And I'm going to go to the Home tab and make these really big and bold, because that's the central limit theorem right there. You're looking at it. If I do this over and over again, you can see that the numbers on the right are roughly trying to be the numbers on the left. And that is the end of the simulation. And I can do that over and over again. And anybody who duplicates this construction and sends it to me in my special Dropbox folder for the course, you're going to get credit for that. Look at that. Isn't that great? That works like a charm.